All right, with the cabinet problem here, when you're doing a linear programming problem or you're using linear programming to help you solve a problem, the first thing you really got to think about is, well, what are the variables we are dealing with? This one was fairly easy to pick out because they talked about cabinet X and cabinet Y. So we want to define our variables. That's really the first thing that we want to set up as we're doing these problems. So this one was actually fairly easy because I just called it cabinet X and cabinet Y. But we should kind of think about, okay, what about cabinet X and cabinet Y? And really, it's the number of cabinets in each case. Sometimes you may be talking about price, sometimes you may be talking about other factors. But in this case, we're talking about how many cabinet X's, how many cabinet Y's. So that's a variable. The second thing we got to start thinking about is, well, what are our restrictions that we have? What are our limitations for this situation? So let's read through the problem here and see what kind of limitations we have. And that's going to help us set up some inequalities. Well, the situation talked about you're going to buy some file cabinets. We talked about cabinet X has a certain cost. It's $10 per unit. It requires 6 square feet of floor space, and it holds 8 cubic feet of files. Cabinet Y, on the other hand, it costs $20 per unit. It requires 8 square feet of floor space, and it's going to hold 12 cubic feet of files. So we've been given a certain amount of money to make our purchase. We've been given $140 for the purchase. You don't have to spend all that, but you can't go over it. The office has room for no more than 72 square feet of cabinets. And we want to know eventually, well, how many of each should we buy in order to maximize our storage volume? Okay, so this is a case where we're looking for the maximum storage. All right, well, our limitations. Well, we basically have 2 sets of limitations. We have limitations on the amount of money that we can use, and we have limitations on how much space we can take up in our office. So let's start with our money. Well, they said that cabinet X was going to cost $10 per unit, and cabinet Y was going to cost $20 per unit. So I'm going to start with that. The fact that 10X plus 20Y would be our total cost. Well, our total cost cannot exceed $140, so it has to be less than or equal to $140. Then we have our limitations in terms of space. So they said cabinet X was going to require 6 square feet. Cabinet Y required 8 square feet. So 6X plus 8Y has to be less than or equal to, they said we had no more than 72 square feet to work with. Those are the 2 limitations we have just in terms of money and space. Something else I'm going to throw in there, and this is the case in most of these problems. Since we're talking about cabinets, we know we can't have a negative amount of cabinets. So I'm going to throw in the fact that X has to be greater than or equal to 0, because I really don't have to buy any cabinet X's. And then I have Y is greater than or equal to 0 as well. So what we're going to do is we're going to use these limitations or these inequalities to help us set up a feasible region. Now, ultimately, I've got a question to answer, and we'll get to that part here in a second. But let's start with our inequalities and what our graph would look like. Now, I'm okay with you using Desmos for a problem like this. I'm going to kind of sketch the graphs on these 2 to get an idea of what our feasible region would be. So when I sketch my graph on this one, because everything has to be in the first quadrant, and that's based on the fact that X had to be greater than 0 and Y had to be greater than 0, I'm going to actually use the X and Y intercepts in order to set up my graph. For instance, on the first inequality, again, we're setting up a border here, so I'm going to treat it like an equation. But if I look at the x-intercept, well, that would be when y equals 0. Or in other words, I'm going to look at when 10x is equal to 140. Well, 10x is equal to 140 when x is equal to 14. So I'm not making an exact graph right now, but I'm going to mark my x-intercept at 14. The y-intercept would be when x equals 0, so that's when 20y equals 140. So that's going to be here at 7. So I'm going to have a graph that's this for a border. Now, as I start thinking about shading, my shading here would be below that line. So I'll kind of keep that in mind. Then we have the other set of inequalities. So 6x plus 8y, I'm going to treat it as equals 72. So the x-intercept here would be when 6x equals 72, or when x is equal to 12. And then the y-intercept would be when x equals 0, so 8y equals 72 when y is equal to 9. And I'm going to connect those two together. Now this is another less than, so I'd be shading below that one as well. So I'm shading below both those lines. We know x has to be greater than 0, so that means above or to the right of the y-axis. Y has to be greater than or equal to 0, so that means it has to be above the x-axis. So the area I'm really going to focus on is this area right here. All right. Answering the question. Well, we're going to use this graph to help us eventually, but we got to think about, well, what's the function we're going to look at? Well, the function should help us answer the question that we want to figure out. Well, remember our question here was how many of which model should we buy in order to maximize the storage volume? So I want some sort of function where I'm going to plug an x and a y value in, and that function is going to tell me how much storage I'm going to have. Well, if you remember, the problem talked about cabinet X's having 8 cubic feet of files. So I'm going to have 8 cubic feet for every X cabinet. Plus, cabinet Y is going to hold 12 cubic feet. So I've got this function, the function that says f of xy equals 8x plus 12y. Now what I need is a set of points that I can plug in for x and for y. Well, technically, any point that's in the shaded region would be a point that I can plug in and check. However, I'm looking for the maximum amount. So I'm going to look for my extreme values. And by extreme values, what I'm talking about are the vertices of this shaded region. So I've got 1, 2, 3, 4 values that I'm going to check. Well, some of those values are easy to figure out right now. For instance, 0, 0 is one of them. 0, 7 is one. And 12, 0 is one. So if I plug those values in, if I plug 0, 0 in, well, that means I don't have any space, which makes sense. If I don't have any cabinets, I don't have any space for files. If I put 0, 7 in, that means I'm going to have 8 times 0 plus 12 times 7. And that'll tell me how many cubic feet. So in that instance, I'm going to have 84 cubic feet. 12, 0 would be 8 times 12 plus 12 times 0. Or that one's a little bit more. That tells me there's 96 cubic feet. So right now, 12, 0 is our largest amount. However, I still have that fourth point. Well, if you use Desmos, that fourth point you can find pretty easily because the technology will help us do that. If we didn't have that, though, what we're really looking at is the intersection of those two lines. So this now becomes another system of equations problem. So if you remember our two equations, our two inequalities, the first one was 10x plus 20y. And since we're focusing on the line, I'm going to say equals 140. The second one was 6x plus 8y, and it was equal to 72. So what I'm going to do is I'm going to solve this system of equations because it's going to tell me where the intersection is. This is kind of set up for an elimination problem. If I were doing this one, I would probably multiply the top by 3, multiply the bottom by 5. That way I can get my x's to match. So if I did that, I now have 30x plus 60y is equal to 420. I have 30x plus 40y is equal to 360. And now I can subtract these two. So when I subtract them, I'm going to have 20y, that's equal to 60, and I find out that y is equal to 3. Now when I plug that back in, I can figure out what x is. So if I plug it in, say, to the second equation, now 6x plus, if I plug the 3 in, I've got 24. And I find out that x eventually is equal to 8. So the fourth point I'm going to check is the point 8, 3. So if I check that, I've got 8 times 8 plus 12 times 3 and 64 plus, oh, I said 3, wait a second. Okay, sorry. So I got 64 plus 36, so that's going to equal 100. And so I find out that 100 is my largest volume that I would have, or the most cubic feet that I would have here. Now, again, if you did Desmos, finding that ordered pair for the intersection was a lot easier, a lot faster. Now, have I answered the question? Well, I need 8 for cabinet X, and I need 3 for cabinet Y. All right, so an example of using linear programming, and it allows us to find a maximum, in this case, amount of volume.